So looking at inverse functions, what we're saying is that when a function f of x is a one-to-one correspondence from set A to set B, another function f to the negative 1 of x exists that maps from set B to set A, and this function is called the inverse function. So if we've got two sets here, set A and set B, the inverse function undoes the original function. So this is a one-to-one correspondence. That means that every value of A has a single value of B. So A maps onto B, and this value of A would map onto a single value of B, and this value of A would map onto a single value of B. So we're saying that f of any value of A in set A is going to give you a single value of B. And because it's a one-to-one correspondence, if we go from B to A, so in reverse, then we can say that f to the negative 1 of b, so the inverse function of b, is going to equal a. And if f of x and g of x are inverses, then f of g of x and g of f of x, using our composite functions, are always going to equal x. So to find an inverse function, we're going to undo the original and swap x and y. So the steps are, we're going to equate the function to y, we're going to change the subject to x, and then we're going to replace x with our inverse function of x, and then the y with an x. So the first example, we're going to find the inverse f of x equals x over 5 plus 1. So the first thing we're going to do is we're going to equate our function to y. So x over 5 plus 1 equals y. Now we want to change the subject to x. So first we're going to take away 1 from both sides, and that gives us x over 5 equals y take away 1. And then we're going to multiply both sides by 5, remembering that we need to put that y minus 1 into a bracket, and we're going to get x equals 5 upon y minus 1. And the final step is to change that to an f to the minus 1 of x. So our inverse function of x equals 5 upon, and then we're going to change the y to an x minus 1. Now, I would always check that you've got the correct inverse function by substitution. So if we say that f of 5, and we've got 5 over 5 plus 1, so that's going to give us a value of 2, then our inverse function of 2 should, and we're doing 5 multiplied by 2 minus 1, which is 5 multiplied by 1, which is 5, give us the value that we put into our initial function, 5, and so this is the correct inverse for my function. So, second example, we want to find the inverse of g of x equals 4 upon x plus 2. So again, we're going to equate our function, 4 upon x plus 2 equals y. We want to change the subject to x. So the first thing we're going to do is we're going to divide both sides by 4. And that gives us x plus 2 equals y over 4. And then we're going to take away the 2 from both sides. So we're going to end up with x equals y over 4 minus 2. And then we need to replace that x with an inverse function of g equals, and we're replacing the y with an x over 4 minus 2. So let's do some checks. This time let's substitute in x equals 1. So g of 1 is going to be 4 multiplied by 1 plus 2, which is 4 times 3, which is 12. And if we put g of negative 1 of 12, so our inverse function of 12 is going to give us 12 over 4 take away 2, which gives us 3 take away 2, which gives us 1, which takes us back to our initial value that we substituted into g of x. So the other way that we can find the inverse is to use that relationship that f of g of x equals g of f of x always equals x if they are inverses of each other. So I'm going to use the fact that I've got h of x equals x squared minus 8, and I'm going to say that I want to work out what h of h to the minus 1 of x is. So what I'm doing is I'm going to replace that x value with my inverse function of x. So I've got h to the negative 1 of x all squared minus 8, and I know that if it's an inverse function, that's going to equal x. So now I want to add on 8 to both sides. So that gives me my inverse function of h all squared equals x plus 8. And now I want to square root both sides to isolate that inverse function of h. So the inverse function of h equals the square root of x plus 8. So now let's substitute some values in to check. So let's use x equals 4. So h of 4 equals 4 squared minus 8, which gives us a value of 8. And if we put the inverse function of 8, we're going to get the square root of 8 plus 8, which is the square root of 16, which is 4, which was the value that I put into my initial function. So if we want to graph an inverse function, what we have to do is reflect over the line y equals x. Because remember, our inverse functions equated to x if we found the composite function of that inverse function. So in this example, we want to graph the function f of x equals 2x plus 3 and f to the negative 1 of x. And we don't need to find out what f to the negative 1 of x, or our inverse function of x, is, because we can do it graphically. So we need to find the intercepts on our x and y axes. So by making x equals 0, we can get our y-intercept of 3. And if we make f of x equals 0, then we're going to get an x-intercept of negative 3 over 2, or negative 1.5. And so if we put our straight line between those 2 points, in order to graph that function, the inverse of that function, what we're going to do is we're going to take that 0, 3, and we're going to make it 3, 0 by reflecting it in that y equals x. And we're going to plot that on. And we're going to take our negative 3 over 2, 0, and plot 0, negative 3 over 2. And again, we're going to take our straight line and we're going to put it through those 2 points. And you can see that they overlap when y equals x. So the final example, we want to show that g of x equals the square root of 3 over x plus 2 is the inverse of f of x equals 3 over x squared minus 2. So we're using that relationship that f of g of x is going to equal x. So we need to prove that that's the case. So what we want to do is we want to find what f of g of x is. So we're going to start off with f of x, and that is our 3 over x squared minus 2. And we want to find what f of g of x is. So what we're going to do is we're going to replace that g of x with 3 over x plus 2 all square rooted. So if we substitute that in place of that x squared, we're going to get the square root of 3 over x plus 2, and that's all squared minus 2. So if we get rid of that square, we're going to end up with 3 over 3 over x plus 2, and we're still taking away 2. Now, if we have a triple-decker fraction, this bottom level becomes a multiplier. And 3 divided by 3 is 1. So we're going to end up with x plus 2, take away 2, which gives us x. And we can say, therefore, as f of g of x equals x, f of x and g of x are inverse functions.